Hi guys, I'm Arpit and I'll be talking about Lamport clocks today. So you must have noticed that we use distributed system a lot nowadays and there can be a problem with the time. There are servers located in different geographical location. As the technology has advanced, we have thousands and thousands of servers that are relocated in multiple locations. So how do we maintain the counter? So for example, we receive messages on WhatsApp. So you have typed a message and then other person has typed a reply. And what if the replication happens such that the reply reaches first than the actual message you sent? In that case, there will be a total problem. Similar in bank cases, we deposit money at one time and we withdraw money at one time. What if the replication happens that the event happens in the reverse direction? So that will be a lot of problem. For instance, in this case, there's a deposit of $100 that happens at server A. So let me say we do plus $100 at server A. Okay, your relative then withdraws $100 from the Europe. So here in the Europe server, it will be minus $100. Now when the replication happens, what if the deposit request reaches later, that is like plus $100, but the withdrawal reaches first, okay, that is minus $100. In this case, the balance reduces first and then increments. What if there was zero balance? Then it will be a problem. In the auditing, there could be a lot of problem. So how do we resolve that? So in this case, we came up with the concept of Lamport clock. So Lamport clock was given in a paper by a famous computer scientist, Leslie Lamport. Now let's discuss how the Lamport clock timestamp helps in case of distributed systems. So in this case, we maintain a counter on each of the servers. So for example, let's take a counter initialized to 0 on server A, that is 0, 0 and 0. The counter increases whenever an event happens and it is not dependent upon the timestamp. So let's see, we deposit $100 in server A. So in this case, so 0 plus 1 is 1. So the timestamp will be marked as 1, comma, the message. The message is plus $100. Now what will happen? We will do the replication to server B and server C. And so let's do on server B. So we send the message to server B. So now what will happen? Whenever we send the message, there we need to do a bit of calculation. It's not very difficult calculation. The only thing is that we need to do max of t dash comma t plus 1 comma the message. So in this case, t dash is the timestamp or the counter received from the previous. So that is max of 1 comma t is the value of the counter of the current server, that is 0 plus 1, which is equal to max of 1 comma 0 is 1 plus 1 is 2, so it will be 2. So the overall message will be 2 comma plus $100. Counter will be at 2 and the message will be plus 100. Now there's another event happened in server B, that we withdraw money from server B. So in that case, what will happen? Since you know this is the same server, we will do a simple increment of the counter by 1. That will be 3 comma message minus $100. Now there comes a scenario where we need to replicate the transactions in server B also, because it has to be on all servers. So in this case, let's take a scenario that maybe server C is already at 3. Okay, it has had 3 events till now. So once we transmit the message to server C, we will do max of 2 comma 3 plus 1 comma plus 100. Oops. Okay, so this will be max of 2 comma 3 is 3, 3 plus 1 is 4, so the counter will be turned to 4 comma plus 100. So here the message will be stored as 4 comma 100. Similarly, we transmit the withdraw, and so now the counter is at 4, we are transmitting 3, so this will be max of 3 comma 4 plus 1 comma minus $100. So in this case, max is 4, 4 plus 1 is 5. So we will go to 5 comma minus $100. So this is how the Lamport log increments the counter in each of the server. There are just two scenarios. One is if the event is happening in the same server, we will increment it by 1. If we are getting a replication copy from another server, we will check the max of the counter between the current server count and the receive count. Whatever is the max, we will take that plus 1 and store the message. Okay, so now I will tell you how we maintain the timestamp on the server itself. So I told you how the counter increase and how we transfer the message. But in reality, there's a format of timestamp we maintain. So the format is LA, NA. So this is how we maintain. So what is this? LA is the counter and NA is the name of the server. So in this case, the counter 0 is maintained like 0 comma A. Similarly, the counter here is maintained by 1 comma A. Now here it will be 2 comma B, 3 comma B, 4 comma C and 5 comma C. That's how we maintain the Lamport timestamp in this case. Okay, so there is one limitation with Lamport timestamp. So there's a scenario that, both the transaction A, that is 1 comma plus 100, and transaction B that happens in server B, that is like withdraw of minus 100, happens at the same time. So in this case, how do you maintain that, how do you maintain which event happened first? What if minus 100 reaches server C first? In case of non-concurrent timestamp, Lamport clock can easily help you with the causality. But in case of concurrent event, there's a limitation with Lamport timestamp. It is not able to tell which event happened first. So for this comes the vector clock. So we will discuss about vector clock in the next chapter, where we will discuss about the problem with concurrent events happening at the same time in different servers, how the causality is maintained, how do we know which event happened first or not. Okay, so till the time, see you. Thank you. Bye.